I'm continuously converting the chapter pressure into the form of question answer, and this is very important for SEE examination. The whole chapter is being converted into the form of question answer with numerical and everything. Okay, let's enter into part 5. This question is related with diagram. In the given figure, an object ABCD is immersed in liquid. Which pressure is greater in AB or CD phase? Why? Look at this. ABCD is an object and it is immersed into the liquid, and in which phase, whether in AB or in CD, the pressure is high. Now what we have to answer, pressure on the surface CD is greater than the pressure on the surface AB, because pressure of liquid is directly proportional to the depth of the liquid. The surface CD lies at the greater depth of water than the surface AB. Hence, the pressure on CD is more than AB. This is the reason. AB is at less depth here and CD is at greater depth, and pressure is directly proportional to the depth. That's why CD experiences more pressure. Okay, next question. Why does a stone sink in water? What is the relation between the density of liquid and the upthrust exerted by the liquid? We can answer like this. Weight of displaced water by stone is less than the weight of stone. According to Archimedes' principle, upthrust is equal to the weight of displaced liquid. So the downward force of the stone, that is the weight, is greater than the upward force, that is the upthrust. Hence, a stone sink in water. We can write like this. The next part of the question is, what is the relation between the density of liquid and upthrust? That's why we have to write this also. Upthrust is directly proportional to the density of the liquid. Okay, next question. Number 53. Write the relation between the upthrust and volume of displaced liquid. What can we write? If a body displaces more volume of liquid, then weight of displaced liquid will be more. According to Archimedes' principle, upthrust is equal to weight of displaced liquid. So, upthrust increases with the volume of displaced liquid. Okay, next question. In the given figure, an egg is shown in water. Which one is seawater and which is river water? Why? Look at this. One of them is seawater, another is river water. Which one is seawater and which one is the river water? It's very simple. Density of seawater is more. That's why dense liquid exert high upthrust, and if egg is floating, it means the second one is seawater. But river water doesn't contain salt and its density is less. That's why egg is sinking. First is the river water. This way we can reply. We can answer this way. Density of egg is greater than river water because salt is not dissolved in it. So an egg sinks in river water. Hence the liquid of first beaker is river water. But the density of seawater is greater than the density of egg because salt is dissolved in it. So an egg floats on seawater. Hence the liquid of second beaker is seawater. Okay, let's go to another. At what condition a body floats on liquid? There are two major conditions. One, if density of liquid is more than the body, then it floats. Another is if the body is able to displace more liquid. I mean to say, if a body is able to displace the liquid equal to its own weight, and then it floats. That's why we can write a body floats on a liquid if its density is less than the liquid, or it is able to displace the liquid equal to its own weight. Okay, let's go to next question. Write any two differences between force and pressure. Force and pressure. We can make a table. In the side of force, we can write force is an agent that changes or tends to change the state of rest or motion of the body. This is the definition of force. Very simple definition. But pressure is force acting per unit area of a surface is called pressure. And second difference is SI unit is Newton, but its SI unit is Pascal. These are the major two differences between force and pressure. Next, a ship coming from sea enters the river. Will its hull sink more or less in river water? Give reason. We have to take care about the density of river water. Sea water has high density, river water has less density, then certainly its salt sink more. So salt is dissolved in seawater but not in the river water. So seawater is denser than river water. A dense liquid exerts more upthrust than the less dense liquid. So the upthrust of seawater is more than the river water. Hence the hull of ship immerses more in river water. What is atmospheric pressure? We can say the force applied by the atmosphere on the unit area of the Earth's surface is called atmospheric pressure. Okay, next question is, write down the standard value of atmospheric pressure in the sea level. It is 760 millimeter mercury pressure. Next, how can we prove that atmosphere exerts pressure? And we can prove it with the help of experiment. In this experiment, we have taken a glass which is completely filled with water. And how can we explain this? This way, when a glass completely filled with water is covered with a paper and quickly inverted as shown in the diagram, then water doesn't fall down. It is due to the atmospheric pressure acting on the surface of the paper. Pressure resists the weight of water. This experiment proves that atmosphere exerts pressure. We can answer like this. Next, what is barometer? Now, what is the answer? It is a device which is used to measure atmospheric pressure. Now, next question. Draw a neat diagram to show barometer with suitable labeling. This is the diagram. This diagram consists of a long glass tube which was previously completely filled with mercury, and after closing its mouth it is quickly inverted into the vessel which contains mercury. A little space is left at the top. This space is called torricellian vacuum. These are the labeling. And we'll get height of mercury 760 millimeter, and this is the case of sea level. In sea level, the atmospheric pressure which exerts on the surface of this mercury makes the column 760 mm. That's why pressure at sea level is 760 mm Hg. What do you mean by the standard atmospheric pressure? And this is atmospheric pressure at sea level is called standard atmospheric pressure. Its value is 760 millimeter mercury pressure. Okay, next question. Why water cannot be used in place of mercury in barometer? There are many reasons. Some of them are written here. Water has very less density than mercury. If it is used in barometer, then column of water in the glass tube of barometer due to the atmospheric pressure will be more than 10 meter. This type of barometer cannot be transported easily and a ladder is needed to take the reading. So the use of water is very impractical. Density is very less. Water has very less density, and that's why very long tube we cannot handle this. That's why water is not used. Water produces lot of vapor, but mercury doesn't. So water vapor gives incorrect reading of pressure. That's why water is not used. Next, water sticks to the inner wall of glass tube, which gives incorrect reading of pressure. These are few major reasons due to which we are not using water in place of mercury in barometer. Okay, next question. What is syringe? Very simple. It is a medical instrument which is used to inject liquid medicine into the body of the patient or to take sample of blood from patient. It is based on the principle that fluid flows from a region of high pressure to the low pressure. This is the principle of syringe. Okay, draw a neat diagram to show syringe. We can draw this way. Look at this, it has got three major parts. One is hollow needle, another is barrel which is also called storage cylinder, and another one is piston. Piston can move forward and backward. Okay, this is the diagram of syringe. Okay, next. What are three major parts of syringe? Just now I told you. Number one, hollow needle. Number two, storage cylinder which is also called barrel, and number three, piston. Next, how a syringe utilizes the atmospheric pressure to fill liquid medicine into it. Now, this is the mechanism of filling of liquid medicine into the syringe. It can be explained with the help of the diagram. Look at this diagram. At this time, we are filling the liquid medicine into the syringe. We can answer like this. When the tip of the hollow needle is dipped into the liquid medicine and piston is pulled backward, then liquid medicine enters into the syringe due to the atmospheric pressure acting on the surface of the liquid medicine, because atmospheric pressure is greater than the pressure inside the syringe. Thus, a syringe utilizes atmospheric pressure. Okay, next. On which principle air pump works? Air pump works on the principle that the air blows from a region of high pressure to a region of low pressure. Okay, next question. Draw a neat diagram to show an air pump. This we can draw like this. Air pump consists of a long barrel which is hollow inside, and a piston moves forward and backward. At the tip of the piston there is a washer, and at the tip of this pump there is metal ball which, when comes back, closes the inlet of the air into the barrel, but when it is moved forward, then it cannot close the nozzle and air goes out from the nozzle. This mechanism is not asked, just the diagram. That's why this is the diagram of what? Air pump. Okay, what is water pump? Water pump is a device which is used to pull underground water and is based on the principle that the fluid flows from a region of high pressure to the region of low pressure. Okay, next. Draw a neat diagram to show the downstroke of water pump and write down its function during downstroke. We are now talking about downstroke. Downstroke means when piston moves downward. Look at this is the diagram. Piston is moved downward. This is downstroke. When handle is pulled upward, piston moves downward. This is downstroke. Okay, now I'm going to explain. As shown in the diagram, when the handle of the water pump is pulled upward, then the piston moves downward. This is called downstroke. In downstroke, the volume between two valves decreases inside the barrel and the pressure on the water in between these two valves increases. At this time, valve B2 remains closed due to the pressure of water, but valve B1 opens due to the upward pressure of water, so water comes up above the piston. Next, in which stroke water comes out of the water pump? This is very simple. Upstroke. Upstroke means when piston moves upward. Where two balls are placed in a water pump? One is placed in the piston which moves up and down along with the piston, but another is placed at the junction of the barrel and underground pipe. One is here, look at this, which moves up and down with the piston, and another one is at the junction of underground pipe and barrel. Next, how the valve opens and closes during upstroke and downstroke of water pump. Now we have to show it with water pump. Look at this here. Valves are shown. We can explain like this. In downstroke, what happens? As shown in the diagram, in downstroke, the valve connected to the piston, that is B1, opens, but the valve lying at the junction of the barrel and underground pipe, that is B2, closes. Here B2 is closed but B1 is open. In upstroke, the valve connected to the piston, that is B1, closes, but the valve lying at the junction of the barrel and underground pipe, that is B2, opens. Look at in upstroke, the upper valve, that is B1, closes, but the lower valve, that is B2, opens. Okay, next question. Draw a neat diagram to show the upstroke of water pump and write down its function during upstroke. This is the diagram. This is the upstroke because the piston is moved upward. Here it is moved upward. Okay, how can we write this? As shown in the diagram, when handle is pushed downward, piston moves upward, which is called upstroke. In upstroke, the volume of the barrel in between two valves increases. This volume increases here and it creates the partial vacuum in the barrel in between two valves. Since pressure in the barrel is less than the pressure of atmosphere acting on the underground water, so the valve B2 opens and water enters into the barrel from underground pipe. But the valve B1 remains closed due to the pressure of water lying above the piston, and therefore piston pulls water out of the barrel through the outlet. Here it is outlet and water is pulled out. I think this is the end of this chapter. and I converted the whole chapter into the form of question and answer. And this is very important for the SEE examination. The whole chapter we have now in the form of question answer, and I want to finish this chapter pressure. But if there is anything left, numerical problem, next class I'll continue the numerical problem, or we'll start next class another chapter. Okay, this much for today.